Hello everyone and welcome to another lecture video here in Earth Science. So this is the part 2 of our discussion about the minerals. So in this particular video, I'll be discussing to you the other physical properties of minerals and at the same time the groupings of minerals. Now, the sixth physical property of mineral is crystal shape. So this refers to the arrangement of the atoms, no? The internal arrangement of the atoms in a mineral. So that's it, no? Pag mas maganda yung crystal shape niya, pag mas regular, or pag mas neat yung arrangement, well arranged yung minerals or yung kanyang atoms, mas mahal yung value ng mineral na yun. No? So, this arrangement is a function of the size, shape, and the molecules and forces that bind them. We have different chemical bondings, di ba? We have ionic, covalent, at yung iba pa, no? So, dito, usually, pag ionic, iba din yung nagiging itsura ng mineral, and then pag covalent, iba rin. So, meron pagkakaiba, guys, sa structure nila. So this indicates or this tells us, this particular property tells us something about the identity of the mineral. So there are minerals na yung kanilang mga atoms naka-arrange in a tetrahedral na na shape. Yung iba naka parang pyramid na shape, yung iba spherical, yung iba irregular. So hindi na tayo magdi-deal doon sa details niya. Okay? So next, number 7 is the fracture. So this is somehow related with the cleavage, guys. The only difference is that in fracture, we are not strict, no? In terms of the fracture. Kasi sa cleavage, merong requirement which is dapat mag-break siya along a definite smooth plane. Here, we are just concerned with how or how minerals break. So that is either a mineral may break into splinter, rough, irregular surface, or di kaya ay shell-shaped forms known as conchoidal fracture. So when we say splinters, for example, this is our mineral. So magbe-break siya into splinters, parang into pieces talaga, guys, na matutulis. So pwede kang masugatan pag natapakan mo itong mga splinters na ito, no? Mga fragments of the mineral na nag-break. So that's it. No? That is for the splinter. Pag rough irregular surface, parang chunks. If this is our mineral, nag-chunks siya, no? Yan. Or di kaya merong mga rough surfaces siya. Medyo malalaki na yung pieces na nag-break, no? Nag-divide into different chunks yung ating mineral. And then for conchoidal naman, fractures, ito naman yung if this is our mineral, meron pa rin siyang shape, no? Yung kaniyang mga nag-break na pieces. Yan. Parang merong shell-shaped na structure yung kanyang pieces. So that is how we describe fracture of the mineral. And again, fracture has something to do or can tell us something about the identity of the mineral. Because there are some minerals that they break in this way, no? Splinter. Meron din mga minerals na nagbe-break through this one, no? Yung kanilang magiging result ganito, no? Regular surface pieces o di kaya ay conchoidal fracture. Yan. So we compare the result of our testing to the known standards or to the known examples for each way of for each type of fracture in a mineral. So, kung sino yung may fracture na ganito, pwede natin compare. Baka isa dito or eto yung nagiging identity ng ating mineral. Yan. And then for the diaphanity, so diaphanity refers to how minerals transmit light. Okay? So, this is different from luster. No? So, luster kasi, guys, how minerals interact with light. So in diaphanity, how minerals transmit light from one side to the other side. Okay? So that is diaphanity. So, somehow related yung tatlo, no? Color, luster, at saka yung diaphanity. Yung color kasi, it is concerned with the reflected light eh. So, yung reflected light niya sa surface, yung nagiging appearance ng mineral. For the luster, how minerals interact. Is it reflecting light or di kaya ay nire-refract na yung light or ina-absorb? For the affinity, paano niya na-transmit? Yan. So we have three, no? Opaque, translucent, at saka transparent. When we say opaque, so it cannot, it is not transmitting any wavelength of the visible spectrum. For example, meron tayo ditong light. Yan. So hindi makaka-pass through sa body ng mineral ng isang opaque na mineral yung wavelengths ng light kasi nga opaque siya. So it cannot transmit light, no? Hindi siya makaka-transmit ng light. Yung opaque, it cannot transmit light. Yung translucent naman, guys, if this is our mineral, so and then meron ditong source of light. So dito, no, selected lang, no. So it can only transmit few wavelengths of the visible spectrum. Hindi lahat, only few lang. Selected lang. Parang slightly lang, no? Slight lang. Yan. So, translucent yan. And then, for transparent, so all or almost all of the light wavelengths ng visible spectrum ay natatransmit niya. Nagpa-pass through sa kanyang body. So, that is what we call, or that is how we describe transparent minerals. No? So, in terms of the affinity, we are concerned with how minerals transmit light. For the luster, how minerals interact with light. For the color, how minerals reflect, or what part of the visible spectrum is being reflected by the mineral. So that is for the color, no? Tatlo yan sila na related. You have the color, the luster, and the diaphanity. They only differ in the interaction with light. Pero they all involve light. Okay, so that's it for the diaphanity. Next, number 8 or number 9 is the tenacity. No? Refers to the ability of minerals to hold together and stick together. So it can either be, or a mineral can be described as tough or durable, and pwede rin siyang ma-describe as fragile or brittle. So usually, metallic minerals, guys, are tough and durable, no? Ano nga yung mga properties ng metals, di ba? Malleable siya, pwede mo siyang ma-shape into wires or ductile. So, matibay talaga yung metallic. While yung mga non-metals naman, gaya ng chalk, calcium carbonate, ano sila, no? Fragile, brittle, parang ceramics. Parang yun yung consistency ng kanilang body. So, you can either describe a mineral as tough or durable, or pwede ring fragile or brittle. So that's it. And then you compare it to those minerals that have this tenacity, tough, durable, fragile, and brittle. So that's it. Next, we go to the specific gravity, or the ratio of the weight of the mineral to the weight of an equal volume of water. So this was devised by Archimedes. No? So the first quantity that was, or the first problem that was solved by Archimedes was to determine the volume of an irregular object, irregularly shaped na object. And then when he was able to determine or solve that problem, he developed the density, the concept of density, and later on the specific gravity. So for each type of mineral, meron silang corresponding na specific gravity. And this is unique, no, for each type of mineral. So that's why it is for me, no, specific gravity is the most accurate way of determining the identity of the mineral. Yan. Kasi yung ibang mga physical properties, guys, ay pwedeng mag-vary. No? Merong mga physical properties just like the color, pwedeng mag-vary yan. Pero eto, yung specific gravity, it is numerical, therefore it is more objective than the other the other physical properties. Just like here, the tenacity. Yung tenacity, medyo may pagka-subjective siya, guys. Kasi yung toughness or pagiging brittle ng mineral ay kung minsan naapektuhan ng weathering, ng mga weathering agents. Diba? Nagiging brittle yung tough na mineral kasi merong na-expose sa acid, for example, sa acid rain or kung anumang mga weathering agents. So, naapektuhan yung tenacity niya. Parang ano siya, no? Nagva-vary siya. Pero yung specific gravity, guys, hindi siya nagva-vary. Therefore, isa ito sa mga pinaka-reliable na basis for identifying minerals, no? Kasi nga, ano siya, numerical yung value dito, quantitative na na values yung kino-compare natin, and it is more objective than those other physical properties of mineral. Okay, so that's it. And now let's go to other special properties of minerals, guys. The taste, the odor, of course, this has something to do with their chemical composition. Yung taste niya, yung odor niya, chemical composition yan. So therefore, they are described as pwede silang i-describe as physical, pwede rin i-describe as chemical properties. Depende kung saan diyang side yung tinutukoy mo. Is it the component or is it just the smell of the mineral? Yan. Kung smell lang or yung taste lang, so pwede siyang i-describe as physical lang. Pero pag yung component niya, for example, maalat yung sodium chloride kasi mayroon siyang sodium at chlorine, so that is already chemical. No? Yan. And then attraction to magnet, so later on we'll deal with this further. And then yung fluorescence or the ability of certain type of minerals to emit light. Radioactivity, nagpo-produce ba sila ng radiation? Or very reactive sila sa mga reagents. So, acid, base, or salt, depende kung saan sila mas reactive. So, nakadepende yan. So, these are chemical properties na, guys. These are chemical properties na. Okay, so, yung 10 na yon, they are physical properties, no? Ito, chemical properties of minerals. Okay, so that's it. The special properties of minerals. And then, now let's go to the most abundant, syempre, no, na compound na na-discuss ko na sa previous na video, yung silicon dioxide or silica. Yan, SiO2. So this is the most common na compound na makikita mo sa karamihan ng mga minerals natin. Yan. So you have here, all minerals are classified on the basis of whether the mineral structure contains these two elements, yung silicon at oxygen, or not. So there are two main groups of minerals, guys. We have the silicates and non-silicates. When we say silicates, they have silicon dioxide or silica in their body, in their as part of their structure, and those non-silicates without. These minerals have no silicon dioxide in their body, okay, in their structure, chemical structure. So wala. Non-silicate at saka yung silicates. Yung pinaka-abundant, guys, eto, silicates, no? So sila yung pinaka-abundant na group ng minerals natin, silicates. They are the most abundant group of minerals. Now let's go to the groupings of silicates, no? Yung groups under silicates. Meron tayong system of grouping silicates, guys. 92% of the Earth's crust, puro lang silicates. So they are grouped into two based on the presence of iron and magnesium sa kanilang katawan, no? Or sa kanilang atomic structure. So iron group at saka yung magnesium group. Parang parang basalt at saka yung granite na group sa rock naman yun, no? Rock na yun kasi hindi na yun mineral, no? And they are generally described as ferromagnetic, paramagnetic, and diamagnetic. So if that particular mineral has a large amount of has a large na quantity of iron na napopossess, so that is described as ferromagnetic or strongly attracted to magnets. So pag ano siya, no? Pag more metallic, no? So mga metallic dito guys, metallic na mga elements. Metallic, no? Mga ferromagnetic. Ibig sabihin, they are strongly attracted to magnets. Paramagnetic, usually they are metalloids. Metalloids, no? Metalloids yung mga nasa slightly attracted to magnet. Metalloids. Sorry. Metalloids. Yan. And then, of course, for the for the diamagnetic or those that are not attracted to magnet, they are usually non-metals. Yan. Non-metals. Non-metallic na mga elements or na mga minerals or silicates. Okay? So that's it. Silicates, you have the group of iron and magnesium, and they are described as metallic, either metallic, no, or ferromagnetic, paramagnetic, and diamagnetic. Okay? So diamagnetic, not attracted to magnets. Paramagnetic, slightly attracted to magnets. Ferromagnetic, strongly attracted to magnets. Now let's go to the non-silicates naman, guys. So we have here the carbonates, the sulfates, oxides, halides, phosphates, hydroxides, and native elements. So yung pinakamalaking group ng mga non-silicates naman or yung mga walang silica ay yung carbonates. So ano yung ions ng carbonates, guys? So yung carbonate ay meron siyang meron siyang CO3 na ion, no? Anion siya. Ibig sabihin negatively charged ion. So that is negative or CO3. Tapos yung charge niya is 2. Negative. Yan. So carbonates, no? So lahat ng mga carbonates merong ganitong ions, no? Anion. Meron siyang free na meron siyang free na or extra na electrons. So, 2 electrons yung extra dito sa carbonate. And then, you have the sulfate. Yung sulfate naman is SO4, no? SO4. At yung kanyang charge is ganun din. Negative, no? Negative 2 rin. Yung charge ng SO4 na anion or sulfate. Then, yung oxide, syempre, meron kang oxygen, no? Oxygen. Yung oxide is oxygen, so 2 rin yung kanyang charge. Yung sulfide is sulfur, so that is also 2 rin yung kanyang charge. Yung halides naman, guys, merong sodium chloride, no? NaCl. Yung phosphate naman is PO4. Ano naman yung kanyang charge? Yan. Yung yung phosphate naman ay merong 3. No? 3 negative na charge. Yung hydroxide is merong 1. OH yan, no? Sodium hydroxide, for example, pang-counter sa acidic na compound, no? So, that is 1. And then, you have the native elements. When I say native elements, guys, they are pure, no? Pure gold, for example, pure carbon, just like the diamond. So, iisa lang, no? Mga example nito, you have the carbon, yung sa diamond, pure gold, pure iron. Yan. So ito yung mga tinatawag natin na native elements. Ito yung mga minerals na mga pure carbon, pure gold, or kung ano pa yung iba, no? Pure gold. Mali yung ating yung ating symbol gold G. That is AU. Yan. So, carbon, gold, or di kaya yung sa iron. Okay? So, that's it. And then, we have here example of silicate minerals, guys. Yung pinaka-abundant na silicate mineral sa inyong book dyan ay yung feldspar. Yan. Followed by the quartz, no? Okay, take note nyan guys. So this one is the most abundant, and then second is yung quartz. And then of course we have here the mica, the amphibole, and the talc. So the amphibole, quartz, feldspar, and mica guys, if you combine them, compress them through heat and pressure, so pwede silang mabuo bilang granite, no? Yung pinaka-abundant na rock sa ating continental crusts, yung granite. So that's it, no? Silicate mineral. Yung quartz, yan lang yung yan lang yung mineral na merong silicon at saka pure silicon at saka oxygen lang, no? Pure silicate siya. Yung feldspar kasi meron pang mga mixture yan or impurities. Pero yung quartz ay pure pure silicon, pure silica siya, yung quartz. And then we have here the non-metallic minerals. Ayan, si calcite or calcium carbonate. Makikita natin yan sa mga sa mga dagat, malapit sa mga lugar na malapit sa dagat, calcite. And then you have the dolomite, napaka-controversial na non-metallic mineral. The gypsum, it is used in in the most scale. Halite is the rock salt. Yan, okay? So that's it. And then we have also metallic na mga minerals, just like the graphite, as mentioned earlier. That is a compound or yung mineral na makikita natin sa lid ng ating mga pencils. Gold ore, ito yung raw na form ng gold. So hindi pa siya na-extract dyan, meron pa siyang impurities yung gold ore. And then the sulfur, medyo mabaho pero antifungal agent ito guys. Silver, syempre, excellent conductor of electricity, at saka yung iron ore, medyo rusty na yung color niya because of the oxidation. No? Yan, yung iron nag-interact with oxygen kaya parang rusty yung iron ore pag nakikita natin in nature. Okay? So, and then you have here the gem minerals or yung mga precious stones, semi-precious stones. Yan, used in jewelry and other body decorations, no? So yan, we have the yung kanyang value, economic value of gem minerals are determined by or is determined by its size, lack of flaws, beauty of color, luster, hardness, and perfection of crystal form. So if it is bigger, it is more expensive. If it is flawless, it is more expensive. If the colors are brighter, so mas expensive. Pag mas shiny, sparkly siya, just like diamond, yung luster niya ay napaka evident, so that is mas expensive. Pag mas hard, mas expensive. Pag mas perfect yung crystal form, mas expensive siya. Aside from the aside from jewelries, we also use gem minerals sa mga decorations sa ating bahay. Mga sculptures, figurines, at kung ano-ano pa, diba? Yung mga gem minerals. So, sa inyong book dyan, meron dyan mga list ng mga important gemstones or gem minerals na pwede nyo ma-check. Like for example, the diamond, which is very expensive, very rare na klase ng gem mineral. Siyempre, you have the emerald, the opal, the ruby, sapphire, which are varieties of corundum na mineral. Alexandrite, amethyst, and you have the Casidony, citrine, and garnet. So these are examples of precious stones. And we have also here some semi-precious stones. You have the jade, the peridot, smoky quartz, topaz, tourmaline, turquoise, and zircons. So these are semi-precious. Ibig sabihin hindi ganun ka mataas yung value nila sa market. Mga ganitong klase ng gem minerals or gemstones. Yan. So here examples. You have the opal, jade. Ito mas valuable sa mga oriental na countries, just like the China, sa Japan. Usually during ancient na mga or dynasty nila, no? So mga dynasties nila, ito yung nagiging part ng mga jewelries ng kanilang mga royalties, no? Mga double officials of the government. And then we have here the corundum. So yan yung maraming varieties, no? Meron siyang sapphire, emerald, ruby, amethyst, and so on. And of course, the diamond. Yan. So in nature, guys, hindi ganito yung itsura ng diamond. Ito ay na-process na-reshape na siya. So mas tumataas yung value ng diamond pag mas na-process na ng maigi. So I think the largest cut of diamond right now is nandyan sa sa scepter ni Queen Elizabeth of England. It was extracted from Congo in Africa, which was once a haven for diamond deposits, pero ngayon syempre overexploited na. And meron din dito sa Asia, no. Sa Papua New Guinea, I think, or sa Timor Leste. I don't know kung saan ba dyan banda yung mas maraming deposit ng diamond dito sa Asia. So that's it, guys. Thank you very much, and see you sa next na lecture video natin. Ang next natin na lecture video is about rocks. Yan. Okay? So thank you.